Okay, today we're talking about dividing polynomials using long division. So this is the first half of lesson number 4. Let's go. So before we do long division with polynomials, let's go back to regular long division. Here I have 72 divided by 12. 72 is our dividend, 12 is our divisor. This is a math fact. 12 goes into 72 6 times. Okay, and then we're done. Here we have 254 divided by 3. 3 does not go into 2, so we combine those two digits, the 2 and 5. 3 goes into 25 8 times, and then 8 times 3 is 24. We do subtraction. The 4 comes down. 3 goes into 14. Let's see, 4 times. 4 times 3 is 12. I use subtraction. I have 2. This is my remainder. Okay, and so 3 goes into 254, 84 and 2/3 times. So now I have 8x squared as my dividend and a 2 as my divisor. And this is going to look kind of funny, but just bear with me here. How many times does 2 go into 8x squared? Remember, this is just one term. Well, it goes 4, and there's an x squared there. Okay, so when I do 4x squared times 2, I get 8x squared. I subtract, and I get a 0. So if you think about this, if you wrote it as a fraction, what you're doing here is saying 8x squared divided by 2. I factor 2 out, and my leftover is up here. The leftover is the quotient. Okay, so let's define some terms that I've been using so we all have common language. So starting with 10x squared, this is our dividend. Okay, with our 3, that's our divisor. All right, up top we have our quotient. This is what you get after you do the division. This is what's left over. And at the bottom, if there's something that doesn't fit, this is our remainder. Okay, so writing this division, 10x squared divided by 3, that equals 3x squared and x squared plus x squared over 3. Right? This is the remainder, this is the quotient, this is the divisor, and this is the dividend. Okay, just abbreviating. Those are not official abbreviations. How I write this as a polynomial, I take my quotient, I multiply it times the divisor, and I am adding the remainder, and that gives me 10x squared. So let's do it. 3x times 3 is 9x squared. 3x squared times 3. If I add x squared, that gives me 10x squared. So there will be times where it says write it as a polynomial, and this is how you write it as a polynomial. When I say it, I mean write the quotient as a polynomial. So from our previous example, the quotient was 3x squared, and our remainder was x squared over 3. And then writing it as a polynomial expression, it's 3x squared times 3 plus x squared. Okay, remember, polynomial doesn't have any rational terms, and all. So here, when we have a divisor, we will have things in the remainder that may have an x in them, but here we don't. So polynomials must be in standard form to do long division. Okay, all terms must be included and accounted for. So if you have an x to the 4th, then you must have an x to the 3rd. If there isn't an x to the 3rd, you write 0x to the 3rd. This sounds weird until you think about, how do you write the number 509? It's 509. There are no tens, so we use a 0 as a placeholder. We're doing the same thing when we use a polynomial, and we're doing division, long division, and there's no term for x cubed or x squared or x. We use 0 as a placeholder. We repeat the process of dividing, multiplying, and then we subtract until we cannot do any more division. And then we place each term that we divide, each quotient of the term goes directly above its counterpart in the dividend. This will make sense. That last part will make more sense as we do some examples. So let's just start into it. This is in your note packet. Okay. Our first problem is 4x cubed plus 2x squared minus 3x plus 10. It's in standard form. Divided by x minus 2. So we look to the x. How many times does x go into 4x cubed? 4x squared times. Then this is how we multiply. 4x squared times x is 4x cubed. Then we do this. 4x squared times negative 2 is negative 8x squared. Okay. We're going to subtract, which really means this sign becomes a plus and this becomes a minus. These cancel, and I get 2x squared plus 8x squared is 10x squared. And then we drop down the 3x term. Then x. How many times does x go into 10x squared? Goes in positive 10x times. And I multiply. 10x times x is 10x squared. 10x times negative 2 is negative 20x. I subtract the entire thing, and I'm not going to do the same thing where I change the sign. These cancel. This becomes plus 20, so negative 3x plus 20 is 17x. The 10 comes down, and we repeat, changing colors to show where we're at here. Now I do x. How many times do I go into 17x? Positive 17 times. And I take 17 times x, I get 17x. 17 times negative 2 is negative 34. I subtract the entire thing. These cancel. I get positive 10 minus a minus 34, which is really just 10 plus 34, which is 44. Can x now, in yellow, fit into 44? No, it cannot. This is our remainder. So the appropriate way to write this is 4x squared plus 10x plus 17 plus 44x minus 2ths. Or we really just say 44 divided by x, or over x minus 2. This is our fraction. It's our remainder. This is our quotient, not spelled with an A. Okay. Moving on. Here our dividend is 15x squared plus 8x minus 12. And now we're dividing by a binomial. Our divisor is 3x plus 1. Let's just do the same thing we did before. 3x goes into 15x squared 5x times, and then we multiply. 15x squared plus 5x, subtract. These cancel, and I get 3x. Changing to blue. 3x goes into 3x exactly once. 1 times 3x is 3x. 1 times, oops, sorry, I forgot to drop this down. 1 times 1 is 1. Subtract the entire thing. These cancel. Get negative 13. And 3x can no longer divide into my dividend. So this is now my remainder. And my quotient is 5x plus 1 plus, well, it's a negative, so let's just go right to minus 13 over 3x plus 1. This is not a polynomial because I have a variable in the denominator. So to write it as a polynomial, my quotient is a polynomial, be 5x plus 1 times 3x plus 1, and then I'm adding my remainder, which is essentially just minus 13. This is a polynomial, and when I simplify and do that, I get this. Okay. We have 6x to the 4th plus 12x squared plus 9, divided by 3x squared plus 6x. Here we will see why we use placeholders. I'm going to write my divisor first. A long division bar. Underneath goes 6x to the 4th. There's no x cubed term, so I use 0 times x cubed as a placeholder. Plus 12x squared plus 0x, because there's no x squared, there's no x term up here, so I use 0 times x as a placeholder, plus 9. And we are ready to begin. So 3x squared goes into 6x to the 4th, 2x squared times. When I multiply these two, I get 6x to the 4th plus 12x cubed. But now you see we have subtraction. This becomes negative 12x cubed, and then plus 12x squared joins the fray on the bottom. All right, 3x squared goes into negative 12x cubed negative 4x times. And so now I multiply again. I just don't want to keep drawing these. Okay. I get negative 12x cubed, so that checks out. Negative 4x times positive 6x is negative 24x squared. I subtract. turns out positive. These cancel, which is good. This becomes 36x squared. Drop down the 0 plus 0x. Switch to green. 3x squared goes into 36x squared 12 times. 12 times 3x squared is 36x squared. 12 times 6x is positive 72x. I subtract, these cancel. I get negative 72x and positive 9 drop down here. Okay, how many times does 3x squared go into negative 72x? It does not. This is our remainder. And I learned a slightly different way to do this, and I'll show you on the next example how I like to organize these. So our quotient is 2x squared. Why did it do that? Minus 4x plus 12. Let's go with a plus negative 72x plus 9 over 3x squared plus 6x. Okay, this is our quotient. That's the answer to the long division problem. This is our last example. I promise. I know the video is getting a little long. My sincerest apologies. X cubed minus 6x squared plus 11x minus 6, all divided by x squared minus 4x plus 3. Now, I'm going to rewrite this using the long division. So I write my divisor first on the left. Or my long division bar, x cubed minus 6x squared plus 11x minus 6. We don't need any placeholders. That's fantastic. Now let me show you how I was taught to organize the information. How many times does x squared go into x cubed? Well, it goes into x cubed, x squared. Sorry, it only fits in once. My apologies, because that's what you get when you left over. So because it only fits in an x time, it goes above the x to the 1. So x to the 1 times x squared is x cubed. Then I do x to the 1 times negative 4 is negative 4x squared. I do x to the 1 times 3 is plus 3x. So I write it above where the same power in the dividend, because you'll see why in a second. It tells me when I run out and I'm done. These cancel. This becomes plus 4, so I have negative 2x squared. This becomes minus 3, so I have plus 8x. And then I bring down my minus 6. Okay, let's change colors. Now, how many times does x squared go into negative 2x squared? Negative 2 times. So you see I have my constant here above the constant. And now I do the multiplication 3 times. These, pretend those go all the way to the side. Negative 2 times x squared, negative 2x squared. That tracks. These should always match. Negative 2 times negative 4x is positive 8x. Oh, that's good news. Negative 2 times 3 is negative 6. What do you know? These are all identical. So when I subtract, all the signs change and they all cancel and I get 0. Remainder 0. So I know I'm done because I just filled in the last spot and it's above the constant. So in our previous examples, I wouldn't have had to check. I would just automatically know this is the last one. Our quotient here is x minus 2. So that means our divisor, x squared minus 4x plus 3, divides exactly into x cubed minus 6x squared plus 11x minus 6. It is a factor of our dividend when r equals 0. And more importantly, we'll talk about zeros and solutions to polynomials in the next lesson. But for now, we're going to stop at that point. We do have an assignment. It's a long division practice worksheet. Some of the sample problems are already in there. Print it out in the library or at home. The link is in the Google Classroom. I hope this was helpful. My apologies for the length. Watch it at 1.25 or 1.5 speed if it's going too slow. You know how to get a hold of me if you have any questions. Good luck.